Welcome to Ask and Learn.
Thing to do here will be to find the final velocity, which will be an entirely y velocity. So we use energy conservation, and we equate kinetic energy E sub k to the potential energy. Potential energy E sub p, and so the final kinetic energy will be 1/2 mvy squared, because it's a horizontal velocity, vertical velocity. It's equal to mass times gravity times height to which the ball rises. And so you have vy equals square root of 2 times g times h. So that's 2 times 9.8 meters per second squared times height, which is 36.5 meters. So final y velocity is 26.75 meters per second. Okay, now we can calculate the force. And so average force is just delta p, rate of change of momentum, delta p over delta t. That's mass times final velocity minus initial velocity over delta t. Okay, and so this will be mass times delta t is what we know. Vf, final velocity, is Vy entirely. There's no x component to it. And initial velocity V naught is just, let's call it Vx because it just has the x component to it. And so, yeah, so let's go ahead and write that out. Average force is equal to mass, which is 0.145 kilograms, over change in time, so 2.5 milliseconds, 2.5 times 10 to the 3 seconds is what that is, times the difference between the final and initial velocities. Now, final velocity, Vy, is 20. So one thing I mentioned here is that velocity is a vector. So this has to be a directional, this has to have a magnitude and a direction. So Vy is just 26.75 meters per second in the j hat direction, or in the y direction. Okay, you subtract from it Vx, and so that's given us 32. But since momentum initially is acting opposite to the bat, it will be negative 32 meters per second in the j hat, in the I hat direction. I mean, whoops. Let's make that clear. In the I hat direction, right? And so you get finally that average force is given by 1856 newtons I hat plus 1552 newtons j hat. Or you could say 1856 I hat plus 1552 j hat, which is altogether in newtons. And that's it.